We are learning about multiplying and dividing radicals. I know I've got this when I can multiply and divide radicals, rationalize monomial denominators, and rationalize binomial denominators using conjugates. Key vocabulary is the product rule for radicals, quotient rule for radicals, rationalizing, and conjugates. So the product rule is that you can multiply radicands, and the quotient rule is that you can divide radicands. So let's multiply them. All right, so 50, since these are both radicands inside numbers, I can just multiply them. And now I get the square root of 30. And then you try to simplify that, but you can't, so you're done. Okay, this one, 15 times 5 is 75. 75 can be broken down to 25 times 3. So that would be 5 square root of 3. This, if I multiply it, would be 12x to the 4th. And so the square root of 12 can be broken down into 4 times 3. So the square root of 4 is 2. I can't do anything with the 3, so I leave it. X to the 4th, the square root of that is x squared. And so those are my final answers. And this actually should have a square on it right there. Okay. All right, here's some for you to do, so go ahead and try. And those are your answers. Okay, 2a. So we're multiplying these, so we're just going to distribute, right? But 6 times 5, the square root of 5 is in a radical, and the 6 is not. So we would have to list it 6 times the square root of 5. And we've got 5 times 50, which is 250, which you can break down, right? Because that's 25 times 10. So 6 square root of 5, the square root of 25 is 5, and then you have that square root of 10 that you really can't do anything with. Okay. Over here, we're multiplying binomials, which means you're going to distribute. So the square root of 11 times the square root of 3 is the square root of 33. The square root of 11 times 2 is just 2 square root of 11. Then you've got the square root of 7, negative square root of 7 times the square root of 3, which would be negative square root of 21. Negative square root of 7 times negative 2 times 2, sorry, is negative 2 square root of 7. And then none of those are like terms because they all have different radicands, so you're done. All right, 2b. Let's multiply this. Okay, so we have the square root of 3x times the square root of 3x, which would be the square root of 9x squared. We're just distributing again, okay? And then you have the square root of 3x times 7. Negative 7 times the square root of 3x. And negative 7 times 7. Now, what I want you to see about this is these will cancel out. The square root of 9x squared is just 3x. And then you have that negative 49. And then here's what I want you to see. These are conjugates. So it's the same binomials with the middle number being different. When this happens, the middle stuff right here will always cancel out. So you really only have to multiply the first and the last, and then everything else will cancel. Also, another thing that I want you to see is when you are multiplying, like I have, let me erase this for a second. When I have the square root of 3x times the square root of 3x, I just get 3x because that would be 9x squared, which simplifies to 3x. So when you're multiplying radicals with the same radicand, basically it cancels each other and you just keep the radicand. Here's some for you to do. And those are your answers. Now I want to show you you can square it, multiply, and double. So let's try this. So let's square this. We get 16 times the square root of 9. Square this, plus 64. Multiply. which would be negative 32 square root of 3, and double, so negative 64 square root of 3. 16 times 9 is, times the square root of 9, which would be 48. 48 plus 64 is 112 minus 6 square root of 3. So that is how you do I. Now you can also, if you wanted to, if you don't want to square it, multiply, and double, you can always write it out twice like that and distribute, and that's fine too. You would get the same answer. All right, now we're going to divide. So this is the quotient rule. So if you have anything under a radical, it will cancel out with each other. So watch, you can write this as all over 1, 15 over 5, which we know is 3. And then that's your answer. With this, 200 divided by 4 can be written all under a radical, and you would get the square root of 50, which can be simplified in the square root of 25 times the square root of 2, so you get 5 square root of 2. Now, many times it's helpful to rewrite a radical quotient with a radical confined only in the numerator. If we rewrite the expression so that there is no radical in the denominator, it is called rationalizing the denominator. This process involves multiplying the quotient by a form of 1 that will eliminate the radical in the denominator. So you need to write this down, rationalizing the denominator, and then that is the process of eliminating the radical in the denominator. So no final answers can have a radical in the denominator. That's why we need to rationalize. So I'll say rationalize the denominator. You just need to rationalize, okay? So how you do that is if you have a monomial in the denominator, you multiply by whatever would complete that denominator. So you would get the square root of 6 over the square root of 4, which would be the square root of 6 over 2. Now, in D, since the denominator contains a cube root, we multiply the numerator and the denominator by a factor that would give the cube root of a perfect cube in the denominator. So what that means is C would look like that, D would look like this. Okay, now let me explain why they're doing 3 square root of 3. Okay, so you have 6 times the cube root of 9, right? Well, we know that a perfect cube, watch, let me show you how we can kind of break this down. 9 is 3 times 3, right? Well, what do we need to complete another one of those? We need another 3 underneath. Because when we do, that would give us a 27. And we know a 27, the cube root of that is 3. And then I can simplify 3 and 6 to just be 2 over 1. So that is your answer. So again, this note, you might want to pause it and copy it. Since the denominator contains a cube root, this part, we multiply the numerator and the denominator by a factor that gives the cube root of a perfect cube, which is why I chose to go for 27 in the denominator. So here are some for you to try. And these are your answers. So please let me know if you're having trouble with any of those. Many rational quotients have the sum or difference of terms in the denominator rather than a single radical. In that case, we multiply by the conjugate of the numerator or denominator, whichever one we're rationalizing. The conjugate uses the same terms but the opposite operation. So these are conjugates. Square root of 5 minus 1 and square root of 5 plus 1 are conjugates. So they have the same terms, but different sign in the middle. So when we are rationalizing that denominator, it's a binomial, right? So in the first one, when we rationalize it, it was the monomial. So we do it differently. When we're rationalizing a binomial, we multiply it by its conjugate, which would be 3 square root of 5 minus 1 on top and bottom. Okay, so in the numerator, you're going to distribute. So 3 times 3 square root of 5 would be 9 square root of 5. And then 3 times negative 1 would just be 3. Now remember, when you're multiplying conjugates, you only have to multiply the first stuff and the last stuff because the middle things will go away, middle terms. So 3 square root of 5 times 3 square root of 5 would be 9 square root of 25. And then 1 times negative 1 is negative 1. So when I do this, I get 9 square root of 5 minus 3 over 9 times 5, because square root of 25 is 5, minus 1. So I get 9 square root of 5 minus 3 over 45 minus 1, which is 9 square root of 5 minus 3 over 44. And that is rationalized and it's simplified. You can't do anything further, so that is your final answer. Okay, now we're going to rationalize this. So it's a binomial, so you multiply it by the conjugate, right? So we're going to say the square root of 2 minus the square root of 3. So you multiply it by the conjugate of the denominator. So let's multiply all this. So we're going to have to distribute. So the square root of 3 times the square root of 2 is the square root of 6. Square root of 3 times a negative square root of 3 is just negative square root of 9. 2 times the square root of 2. And then 2 times the negative square root of 3. Over the conjugate, square root of 2 times the square root of 2 is just 2. Square root of 3 times negative square root of 3 is minus 3. Now let's simplify as much as we can. Okay, so we got square root of 6 minus the square root of 9, which is 3, plus 2 square root of 2 minus 2 square root of 3, all over a negative 1. Because it's divided by a negative 1, I would have negative square root of 6 plus 3 minus 2 square root of 2 plus 2 square root of 3. And you can't do anything with that any further, so that's your final answer. Okay, here's some for you to do. Go ahead and pause it. And these are your final answers. So please let me know if you're needing any help with these. I know I've got this when I can multiply and divide radicals, rationalize monomial denominators, rationalize binomial denominators using conjugates. Do you really understand? Explain how to use the distributive property to simplify the square root of 2 plus the square root of 6 plus 3. Then show the result of the first step. Okay, so you multiply each of the terms in the parentheses by the square root of 2, and the result would be the square root of 12 plus 3 square root of 2. Remember, that's just the first step. Explain how to simplify 4 over the square root of 5 by rationalizing the denominator, then simplify. So you would multiply both the numerator and the denominator of the fraction by the square root of 5, and then you would get the square root of 4 times the square root of 5 over 5.